Now the next problem is the respective number of significant figures for the numbers 23.023, 0.0003 and 2.1 into 10 to the minus 20 minus 3 are. Okay, now this is a very simple problem. In 23.023, all the digits, that is 1, 2, 3, 4, 5, they are significant because this 0 which is coming in between two non-zero digit is also a significant figure. Okay, so this has got 5. In the case of 0.0003, the leading zeros or the zeros to the left of the first non-zero digit, they are insignificant. So this and this, they are not significant. Only 3 is significant, so you have one significant digit in this number. 2.1 into 10 to the power minus 3. When the number is written in exponent form, that means you have to count the significant digits only of the numerical portion and ignore this portion. That means the number of significant digits are 2. So the answer is 512. Option A is correct. Okay, just go through the rules once again. In 23.023, a 0 becomes significant figure if it appears between two non-zero digits. In this number, leading zeros or the zeros placed to the left of the number are never significant. So only this one is significant. In exponential notation, the numerical portion gives the number of significant figures. So this will give you number of significant figures. Now let us look at the next problem. In a series LCR circuit with the resistance R equal to 200 ohm and the voltage and frequency of the main supply is 220 volt and 50 hertz. On taking out the capacitance from the circuit, the current lags behind the voltage by 30 degree. On taking out the inductor from the circuit, the current leads the voltage by 30 degree. We have to find out the power dissipated in the LCR circuit. Okay, so the circuit is somewhat like this. You have R, you have C, and you have L, all connected in series. Then the main supply, which is 220 volts and 50 hertz. Now in the first case, when we take the capacitor out, so we have only L and R. Okay, and in this case it is given that the voltage is leading the current and voltage by an angle of 30 degree. So if you make the impedance triangle, we will get XL and R with this angle as 30 degree. Okay, now when we take the inductor out with capacitor in the circuit, it becomes RC circuit, and in this case it is given that current is leading the voltage by an angle of 30 degree. That means the impedance triangle will be like this angle being 30, this is R and this is XC. Now the value of R in both the cases is 200 ohms. So from this you can conclude that XL and XC, they are actually equal. So XL and XC, they are equal. That means in the LCR circuit, the voltage drop across inductor and the voltage drop across capacitor, sorry, this is capacitor and this is inductor, will be equal and opposite, and the entire potential drop will be across the resistor. Okay, the voltage drop of capacitor and inductor will be exactly out of phase. So this is a case of resonance, and in the case of resonance, the value of cos phi or the power factor is 1. Okay, because phi is 0. So power will be given by V square by R. Cos phi is 1. V square is 220 squared divided by R is 200. So this will be 11 into 22, which is 242 watts. Okay, very simple problem.